Step inside the world of quality engineering and find out how we catch issues before they catch you. Please welcome CCP Amos and CCP Hawk to the stage.
Thank you very much. Hello, everybody, and welcome to Fanfest. I'm CCP Amos. CCP Hawk will join us a little bit later. I'm a senior quality engineer at CCP Games. I've been with the company for more than 5 years, and I have more than 10 years of experience in the industry. I'm a backend engineer. I work with the Quasar communication layer. I have background in big data and distributed systems, and I'm very passionate about everything related to quality, automation, DevOps, and I'm very excited to share my passion with you today. Sorry. All green on the testing front, the art and science of quality engineering. And the first question, what is quality engineering? You may have heard of different terms such as QA, QE, or QC, but what do they really mean? There is a lot of confusion about these terms because they are often used interchangeably within different organizations. But in fact, they are not the same thing. These three disciplines represent different aspects of quality management. Let's start with quality control, or simply put, testing. Quality control focuses on finding defects in the product. It uses the validation process. In other words, are we building the right product? But finding defects in the product is not the only way to address quality. We can also prevent defects from happening in the first place, and this is where quality assurance comes into play. So quality assurance focuses on preventing defects in the product by establishing and adhering to defined processes and quality standards. It uses the verification process. In other words, are we building the product right? Versus are we building the right product in terms of quality control? Now, quality engineering, which is the main topic of this conversation, blends elements of quality assurance and quality control and focuses on embedding quality directly into the development process with an emphasis on automation and continuous improvement. In other words, how can we build quality into the software development lifecycle from the start and continuously improve it? To answer this question, we have established a set of goals that we want to achieve with quality engineering at CCP. Our first goal is prevention and early defect detection. This is very important because the earlier a defect is found, the easier and less expensive it is to fix it. In order to achieve that, at CCP, we apply a shift-left approach to testing. Traditionally, testing is conducted at later stages of the software development process. When the product is almost ready, and then you give it to your quality control team, they run some tests, make sure that everything works. With luck, find some bugs, then you fix them, and then you have to repeat the whole process. Obviously, this takes a considerable amount of time. So shift-left approach emphasizes testing at earlier stages of the software development process. For example, at CCP, we run static code analysis tools that analyze our code for various security vulnerabilities, potential memory leaks. They can also detect outdated versions of libraries, and so on. We also involve our quality specialists earlier into the software development process, beginning from the requirement gathering phase. This ensures that they have a good understanding of the overall implementation, and they can also give us valuable insights in order to make our architecture more transparent and resilient. And then we also write a lot of automatic unit, integration, system-level tests that test isolated pieces of the system instead of waiting for the whole thing to be ready. And the framework we use for that is called test-driven development, or TDD. Traditionally, we write code first, and then we write tests to cover this code. In test-driven development, we write tests first, and then we write code to pass these tests. And this ensures that our code is testable, that we have a good test coverage, and a good quality of our code. And to wrap this up, we have a number of quality standards that all our services should adhere to in terms of performance, security, test coverage, and so on. Our next goal is integration into the entire development lifecycle. This requires collaboration across all team members, production, engineering, operations, and so on. And this requires us to shift from the traditional view of quality as the sole responsibility of the quality specialist to a model of a shared ownership where the entire team is responsible for quality. And the framework that allows us to facilitate this transition is called DevOps. Our next goal is continuous feedback and improvement. And this is the cornerstone of quality engineering, because as quality engineers, we constantly seek to improve our processes, refine our practices, and adopt new technologies in order to ensure that the development process evolves in alignment with best practices. In order to receive continuous feedback, we build continuous integration and continuous delivery pipelines that continuously build our code, run automated tests, and deliver it to our test and live environments. And of course, we track different metrics and key performance indicators, because in order to improve something, you need to know how to measure it. Which brings us to our next topic, measuring quality, introducing scorecards. A scorecard is a set of criteria we apply to our services in order to ensure that they meet defined quality standards. The tool we use for that is called Compass, and it is a service catalog that allows us to keep track of our services, and currently we have more than 70 of them, and associated metrics and scorecards. Here you can see the skill plan service and associated scorecards and metrics for it. The first scorecard is the service definition scorecard. It contains basic requirements for a service definition, repository, Slack channel for communication, and so on. Then the design review scorecard is the biggest one in terms of how many criteria it has inside. And it has various requirements for the service architecture, security, performance, and so on. Then our code-based fitness scorecard tracks the quality of our code base, including the test coverage, number of vulnerabilities found by the static code analysis tools, different versions of libraries to make sure that we don't use anything outdated, and so on. And these are internal metrics that we track, but we also want to ensure that we deliver the best possible quality to you, our players. In order to achieve that, we use something we call service level objectives, or as we call them, API for your engineering team. A service level objective is a target value or a range of values for a service level that is measured by an SLI, or a service level indicator, which is a quantitative measure of some aspect of level of service that is provided, for example, latency, error rate, throughput, and so on. And then the error budget is the margin of error permitted by a service level objective. I swear it will make sense in a minute. So here we have a skill plan service and a service level objective for it that tells us that 99.9% of requests are successful and faster than 200 milliseconds. And then we track it over the 7-day time period. And then below you can see the error budget burn down. And at this point, you may wonder, why can't we provide 100% level of service? Because obviously we want to provide the best quality to our players. And the answer to that is that according to the SLO theory, it is both unrealistic and undesirable to insist that SLOs are met 100% of the time, because doing so would require overly conservative and expensive solutions and would significantly slow down the speed of development. For example, if you go to measure cloud providers, such as Amazon, Google, Microsoft, you'll see that none of them provides 100% level of, for example, availability. And so instead, we have this error budget that burns over time, and we track this for all our services. And what happens if the error budget is exhausted? This means that a given service does not meet our quality requirements, And we can use this information to prioritize the work to bring this service up to our quality standards. And if we track this information for all our services, then this is how we can ensure that they all meet our defined quality standards. And of course, tracking all this information requires us to heavily rely on automation, as we don't gather all these metrics manually. Which brings us to our next topic, codifying quality, test automation plus CI/CD. CI/CD stands for continuous integration, continuous delivery, which is a process of integrating our code changes into a shared repository and continuously delivering it to our test and live environments. Here you can see a CI/CD pipeline for the skill plan service, which is responsible, obviously, for skill plans. It has a build, lint, and test configuration that continuously build our code, run static code analysis tools, or in software development, we call them linters, and also automated tests. And if that build is green, then it gets automatically deployed to our dev environment. And from there, we can also choose to deploy it to our test environment, where our quality control team takes over and runs all sorts of end-to-end tests to make sure that the whole system works as expected. And if all is green on the testing front, then we can deploy that service to our live environment, and at that point, it would end up in tranquility. So this is how this pipeline works. And here you can see the technology stack we use to facilitate all of this. Our version control system is GitHub. Our continuous integration server is TeamCity, and this is what you're looking at. Our infrastructure as code tool is Terraform. Our orchestration engine is Kubernetes. So basically, we build our services as Docker containers, and then we deploy them to our Kubernetes cluster. And for observability, we use Honeycomb, Sentry, Grafana. All these tools allows us to keep track of various metrics, SLOs, errors that users get, and so on. So this was a very brief introduction into basic quality engineering principles at CCP, and it's been more of a theoretical part from my side. And with that, I would like to invite on stage CCP Hawk to talk about how these principles were used to facilitate the quality engineering journey at Team Payments. Please welcome CCP Hawk. Thank you very much.
Thank you. Thank you so much, CCP Amos, and everybody for coming. Now, who am I? I'm CCP Hawk. That's me during last Fanfest. I have a bachelor's in mathematics and a bachelor's in computer science from the University of Iceland with a year abroad at the University of California, Santa Barbara. I've been in software quality for nearly 10 years and at CCP for over 5. Also in my free time, I play a whack ton of video games. These are some of the ones I've finished in the past decade or so. I'm the quality engineer for Team Payments. Now, Team Payments is responsible for enabling you to purchase digital goods using real money, the Plex Vault, and enabling you to purchase digital goods using Plex, the offer catalog, so storing and providing access to offer information like pricing, included products, and so on. The fulfillment of digital products, so ensuring that you get what you pay for, and related services like the recruitment reward service. Team Payments has, in the last couple of years, integrated some of the quality engineering methodology CCP Amos has been telling you about. So what changes and benefits have we seen? Well, we're a bit unique within the company in that we primarily use .NET and C#. And as a result, we had a unique CI/CD pipeline. So here's the Payments pipeline circa 2023. .NET is a Microsoft product, so it has tight integration with other Microsoft products, such as the Azure DevOps cloud computing platform. We, and we alone pretty much, were using Azure repos for distributed version control, Azure pipelines for build services, and Azure artifacts for library artifact storage. The issue with this is that we were pretty much the only team at the company using these, and so it was difficult for us to get support internally. And it's expensive to use and pay for multiple DevOps platforms within a single company. Now, on the other side here, we used the internal repository registry for application artifacts, and we deployed them using the internal deployment console to each dev and test server. However, these are both aging systems that we're looking to deprecate as they're getting quite antiquated. So, in comparison, here's the payments pipeline today. You'll recognize some of these names and logos from CCP Amos earlier. Most of our projects are now in GitHub, built in TeamCity in concert with the backend services at the rest of the company. We use AWS Code Artifact for our library artifacts, and our applications are now built into Docker and stored in Amazon's Elastic Container Repository. We then use TeamCity to deploy them to our Kubernetes cluster via Terraform. And now, instead of deploying individually to each dev and test environment, all our services are now multi-tenant. So we only need to deploy them once to each tier: dev, test, and live. This is largely the same pipeline as the rest of our backend services now, and is using modern technologies to improve efficiency and robustness. Along the way, we picked up some of the other technologies our peers have been using. For example, here's a look at our tracing, circa 2023. This is a screenshot from Splunk, our older log viewing software. We also do use this a bit still, but nah. It reads text logs. It has features like reporting and alerting, but is ultimately limited by its ability to parse the logs from whatever application. As an example here, I've searched for a random user ID. It turns up any logs that contain that user ID in the text. I can further narrow that search down with more text contains searches, or by addressing some of the fields here that Splunk has managed to parse out. But what if we eliminated the need for parsing entirely? Here's what tracing looks like today. Rather than simple text logs, we use OpenTelemetry and its spans. Those spans have attributes that can be read directly by the observability platform Honeycomb, and used to do analysis, reporting, etc. out of the box. An example of an attribute can be eve.user.id to get the Eve user ID that we have addressed directly here, and that will give us all spans pertaining to the activity of that user. Here in the middle, we can see a heat map of the duration of each of these activities. You can see the ones taking a particularly long amount of time, probably a purchase being completed. But all of the action is happening during a very short time span there, because this is an automated test user that is created, does a bunch of stuff, and then is left alone. Down here, you can see all the different events and requests pertaining to that user. And then you can analyze that data with some really powerful tools. The spans also each have a trace ID, allowing us to closely follow the code path of any operation the span is part of. Like the trace here for rebilling an Omega subscription. We can trace the code path of that request to pinpoint any issues, slowdowns, errors. We can see here that a request is sent over the Eve Service Gateway, our internal communication layer, to the SIS, the Customer Information Service, to check whether the user has been banned, in which case we wouldn't want to rebuild them. We then again pull SIS for information about which offer should be purchased, whether it's 1 month, 3 months, 6 months of Omega, or so on. Get the offer ID and pass that to eVirtual Goods. And then the trace goes on to list all of the steps, the purchase itself, and so on. And we can analyze this to see any errors, any slowdowns. Of course, Our migration does not exclusively involve us adapting our processes to those of our peers. We do still use .NET a lot, though some of our projects are now in Go. So in some cases, that means we're adapting the processes to our pipeline. For example, the code-based fitness here in Compass, this one, the original one, is quite specific to Golang. So we created our own version for .NET with .NET-related metrics and so on. And hand in hand with this migration of our CI processes, we've completely transformed our quality strategy. Over the past year and a half or so, we've gone from mostly manual testing to mostly automatic testing by creating a suite of automatic regression tests that have nearly completely replaced our manual testing before release. Now, to be clear, this is just for team payments and services and does not replace unit and integration tests. These are end-to-end tests that run against a live testing environment, closely mimicking a real user's behavior. Now, where before our testing process was manual, it is now automagical. Manual testing requires active attention while testing, while an automatic test will leave you alone until something goes wrong. Manual testing can be very tedious, but programming is fun. And most importantly, when you change something and thus invalidate previous manual test results, refreshing those results requires repeating work. While with an automatic test, the computer does all the work of refreshing the results. Here, you can see our main test suite running. Using Playwright, a web page testing tool by Microsoft, it runs multiple tests in parallel, each going through their own user's flow. Some making simple purchases, others going through more complicated actions, such as purchasing Omega and going through a whole rebilling cycle. And we can use this to validate a wide variety of things along the way. You can see the Teams products are mostly APIs, so most of the tests are just interfacing with those APIs. But there are certain things that require interfacing with a website. Here, for example, you'll see ESP popping up, the Eve admin interface, popping up in various windows here, checking things like a user's redeem queue, character transfers, and subscription status. Also payment flows, like the credit card payment flow over there that just disappeared, and PayPal's payment flow require interacting with third-party websites. So we need to use Playwright for that as well. These interactions, as you can see, mostly take milliseconds, barring some longer things like completing purchases. Thankfully, Playwright supports C#'s easy-to-use async await pattern. So while one test is waiting on a long operation, another can run on that CPU thread. Now, I'd like to give you a look under the hood of an early auto test. If you weren't here for code, buckle up. This automated regression test has changed a fair bit since it was initially made, but the general structure is still there. Each of these tests lives within its own class, with the parallelization scope set to self, meaning that it can run in parallel with other tests, but not other instances of itself, because some of these will run multiple times with different input data. And being within its own class is also required by the default Playwright behavior, which will open up a new window and close it down for each test. So if multiple tests were in a class, it's stored in a class property, so they would interfere with each other. Now, at the start of the test here, we validate that some vital systems are online and running. We then store some data that we're going to use in the test, like the fake credit card data and the offer ID that we're going to purchase. We then create a user using the user builder and get a user helper. We save the API helper from there and get some data about the offer. Then the party begins. In this next step, we call our purchasing endpoint directly. From that, we get a redirect URL to the third-party payment provider that we then need to open in Playwright. We do so. We input the fake credit card data we had, and we make sure that we land on the page we expect. Then we validate that some of the data returned was correct. And finally, we validate that the offer was fulfilled. Now, we have multiple different test projects. And a lot of this process, like creating a user, is thus in a shared library. But that library needs to be pretty extensible for project-specific features. Extensible like the user helper. The user helper is created by the user builder, and it inherits from the type dictionary cache class, a thread-safe, in-memory cache key to the object type. Using that, I can safely store and fetch properties to the user helper at will, and could create extension methods in the consuming project to add whatever functionality I need. For example, here on the right, we have extension methods used to interface with a concept entirely foreign to the library version of the user helper, namely the fulfillment validation engine. Fulfillment is ensuring, the action of ensuring that you, the user, get what you paid for. In our case, it means ensuring that any digital goods you purchase end up on your user account. From Omega time to in-game items, even things like subscription activations and character transfers are special cases of this. But validating that all the products of an offer or a complex set of offers have been fulfilled to a user is a time-consuming process. Until, of course, you have the fulfillment validation engine do it for you. It begins by fetching the user's state that has previously been stored in the user's type dictionary cache blob. It then goes on to get the offer information and works out from that what products should be fulfilled. The offer information is, of course, cached, so it's going to be shared across all the different tests that use the information for those given offers. It then collects and updates the state of the user to its current state and compares it to the previous state and ensures that any changes are in line with the products that should be fulfilled. For example, here for the Eve items, we checked that the redeem queue before only has new items that should have been fulfilled using the offers that were purchased. Now, finally, I want to leave you with a more modern test. This test creates some redeemable codes, and you guessed it, redeems them. You'll notice how it's broken into different methods. This required some finagling, creating a custom page test class, basically, to have a single shared window between all of the steps that then will run linearly in series. But this way, it gives us clearer points of failure. Whenever one of these fails, it stops any subsequent test from running and tells us exactly in a very small code snippet where something went wrong. But ultimately, of course, we want it to be all green on the testing front. When written properly, a fully passing suite of automatic regression tests gives us solid confidence that the tested code and its integrations are ready for release. Confidence achieved with remarkable efficiency. That way, these regression tests and other process improvements speed up development by giving our developers faster and more comprehensive feedback than would otherwise be feasible. They bring us peace of mind that we can deliver a high-quality product by continuously ensuring that it functions as intended. And finally, some would say most importantly, it's just plain fun. Now, we have time for some Q&A. So if our mic runners here are ready, and please join me again, CCP Amos. If you have any questions for us, please go ahead and raise your hands, I guess. can't see anything. So I have no idea whether anything's happening. Oh, there's a hand over there.
Hello, thank you for the nice presentation. Do you introduce any network degradation tests in your automation or maybe manual testing, like direct disconnects or bad internet bandwidth, latency, and so forth?
So at least in my own testing, like negative testing on that level, we haven't gotten into a lot. I've done some stuff with invalid payment information, but stuff like that will mostly be done manually if we go ahead and do it, yeah. Have you done any of?
We have some performance tests in Quasar, but yeah, not to that degree. So it's still a long way to go, I would say.
Yeah, there's definitely stuff to do, yeah.
Thank you.
We fight flackiness in integration testing.
Oh, this is my favorite topic. This is what I do all day, every day. So, like these are dev and test servers that we are working with. So there's an inherent level of flakiness that we're just gonna have to live with because, like, yeah, like it's built to be able to push bad code, basically, that we then catch there instead of letting it get any further. There's a lot of stuff I do. I try and ensure order of operations is correct. Before I check that fulfillment has gone, before I check any like fulfillment specifically, like checking if a given EV item has gone through, I wait for certain events that get thrown. And like if those events don't come through, there's something like inherently wrong there. Mostly it involves just ensuring that tests are failing at the right point so that it gives us good information about what is wrong on our test server right now. Is it the new code that was pushed, or is it some other networking or whatever? Yeah.
Hey guys, thank you for the presentation. Wanted to ask a very strange question for CCP Hawk. Can you please tell the weirdest user behavior during the regression test in payment? I mean, what is the weirdest behavior you test?
That's an excellent question. Most of it's pretty, I would say, vanilla. The weirdest is probably what I was talking about earlier, the negative testing, where I input completely invalid payment information that we then send over to a third party who stores it and gives us back a live saved payment token that is broken and will not work. So whenever you save your card, like you input your credit card, you're like, oh, save this card for later. Then we get a payment token that we store. We don't store any actual credit card information. And yeah, one of the weirdest things I do is like deliberately send over invalid data that where the payment will initially go through, but the token will come back broken.
Sorry, it wasn't working before. Now it's scary loud. So I've worked with like Cypress and Playwright before for automated testing, and I tend to find that they're really annoying to work with when it involves API requests because they do not care when responses come and pages that are being generated do. So did you have a lot of fun with, I don't know, working with automated tests and the fun of asynchronous?
Yes. So Cypress, actually, I tried out a couple of years back. I if I recall correctly, it's like mostly JavaScript stuff. Either way, I didn't really end up using it that much. But once I got into Playwright, Playwright is available for a bunch of different languages, including JavaScript, TypeScript, Python, I believe, and C#. I have a fair bit of experience with C#, and it's like async await stuff is really robust. So yeah, I've had a really, really good time working with Playwright. I haven't been in any sort of contact with Microsoft directly or anything, but it's been a really easy and robust to use. And it's C#, so there are other libraries that I can use to make API calls as well. Some of this stuff I'm using Playwright to use API calls, but other stuff I'll just use the sort of default HTTP client. And I just, async and await for the calls to finish. So that's like ensuring that everything is running in the correct order. Yeah. Got a couple of hands here, yeah.
What's the general ballpark of how many tests you have and how long do they take to run?
Good question. The main test suite has about 100 tests right now. So some of those are like these step-by-step tests. So each of those steps will count as a single test there. But most of those are still in the old format where it's just a one big thing. We also have some other test suites. They have between 20 and 80, I believe, tests each. The longest running one is the main one, because that is dealing with, purchases through our third party. Those can take seconds upon seconds, which doesn't sound like a lot, but it really adds up. So that is taking between 15 and 20 minutes right now. Yeah, the only thing we can really do to mitigate that is just fewer tests and longer tests that cover more things at once as well. Yeah.
I was wondering, with the current setup for the quality engineering, of course, quite recently moving over to how it's done now with team payments and a little bit ago with Quasar. If you could tell us maybe a bit about the kind of cultural shift within the company of moving over to these methods.
Yeah, you want to start?
Yeah. Like I said earlier, it really requires us to do a culture shift, to shift from the traditional view of quality as the sole responsibility of the quality specialist to a model of a shared ownership where the entire team is responsible for quality. And this, of course, requires us implementing a lot of education for our employees, and yeah, it's a long process, and it's definitely like a big culture shift that we are currently trying to make. We started with Team Quasar, then we continued to Team Payments, and we are now trying to bring these two teams together in terms of the technology stack we use and all the processes, and from there we are planning to expand to all other teams.
Yeah. And we had a lot of support from Quasar. Getting team payments into this. It's been quite the process, but as we started seeing the benefits of the more modern way of doing things, we got really excited and into it as well. Yeah.
Hey, so payments, right? It's pretty important that the users can pay, etc., and buy goods. So. In relation to SLOs, which Amos mentioned at the start, is there ever a scenario where the SLO is below 100% pass rate for payments, where you accept tests failing?
So we totally accept payments failing. A lot of the time it's not our fault, sometimes it is. But payments can fail for so many reasons, right? Sometimes there's not enough credit on the card or whatever. Sometimes the bank is having network issues. So we have different ways of measuring and trying to pinpoint, like, okay, when is this something that we need to deal with? SLOs is definitely one of those tools, but we also just sort of monitoring and metrics in general, like Grafana and Sentry will often tell us information about like where the problem lies with payments. Yeah.
But I'm more talking about in your test environment, right? I'm talking about in your automated test suite, etc.
Yeah. So sorry, could you repeat the question?
Right, you develop the software, right? And the ability to pay, and I assume you're testing it on a test environment before it goes in front of users, right?
Exactly, yeah.
So is your no-go, no-go criteria always 100% pass on all tests that you run before it faces a user?
Pretty much, yes. Like we need the full test suite to pass, unless there was like some hypothetical special case in which we had changed something and not had time to change the automatic tests. But like otherwise, it would be too risky, basically, to release. Yeah.
Thank you.
We have time for one more question. Going once, going twice, and sold. All right, thank you so much for coming, everybody.
Thank you very much.
And we'll see you at the party on top of the world.